the industry and everything. So depending upon in which area the embedded systems are used. So here it is divided into several classification areas or the application areas. Okay, so in which the first one is the consumer electronics. What is the problem here? So in consumer electronics, we will take the example of just like the camcorders or cameras. So these are the consumer electronic space where this embedded system is used. Second, this embedded system is used into the household applications. So the household applications, just like a television system or just like the oven or the refrigerators. So likewise, in different applications here, household applications, this embedded system is used. Okay. Then also we can see the washing machines, okay, or CCTVs. Not CCTVs, but just like a DVD players, television system, set-top box, then fridge, microwave. So these are the household applications where this embedded system is used. Okay. Third, more this embedded system is also used into the home automation system. So in home automation, or we can also say like the security systems, so CCTV cameras are there, then air conditioners, then just like intruder detection alarms. Okay, so in such a way, here in for home automation or for home security, security applications, so these embedded systems are used. Okay. Again, these embedded systems are also used into the automotive sector. Okay. So in automotive industry, here this embedded system is used for configuring the ABS system, that is anti-lock braking systems, then engine control, ignition control, then automatic navigation. So in such a way, here the say embedded system can be used into the automotive industry also. Then again, this embedded system is used into the telecom industry. So in telecom industry, where this embedded system is used, just like manufacturing of the mobiles or manufacturing of the telephone switches, then multimedia applications here. Here, this embedded system is used. Okay. Then in fourth, for computer peripherals or computers, the embedded systems are used. So just like computer peripherals, just like we can say the printers, then cameras, also fax machines. So designing of these computers, printers, cameras, etc. These embedded systems are used. Okay. Then also for computer networking system. So in networking system also the embedded system is used. Okay. So for designing of the routers, the switches, then hubs and firewalls. So for this designing, this embedded system is used. Again, into the healthcare industry. So in healthcare industry, just like designing of the different scanners, then ECGs, EEGs, then for designing of the ventilators. Okay. So in such a way, in healthcare industry also, this embedded system is used. Okay. Again, the embedded system is used into the major instrumentation. So for designing of the instrumentation. So in the instrumentation here, measurement and instrumentation devices, just like DMMs or CRO, logic analyzer, PLC systems. Okay. So for in such designing here, this embedded system is also used. Then again, this embedded system is used into the banking industry or banking sector, okay, for designing of the ATMs or the currency counters. Okay. Then also for point of sales. So here, in such a way, here this embedded system is used into the banking industry also. Then for card readers, also, this embedded system is used into for designing the barcode scanners. Then barcode scanners. Then for smart card readers. Then for handheld devices. Okay, just like handheld scanners and IR sensors. So in such a different sections, this embedded system is used. Okay, so there are different applications of the embedded system which can be used into the different areas or different sectors into the day-to-day life. Okay. Now we will see the purpose of this embedded system. Why these embedded systems are purpose of embedded system. So how the embedded system is work, depending upon that, here we have the different domains. Okay, just like consumer electronics or home automation, whatever the applications which we have seen. So for these domains here, every domain or every device is having different applications, as well as it has the different functionality. So depending upon that functionality here, what we need to do, we need to make the different combinations of embedded systems. Okay. So if suppose we want to make some sort of analysis of data, or if we want to make any manipulation in the data, or we want to transfer the data from one section to another section, or from one location to the another location. So these are the different, depending upon such different applications, here the different functionalities of that particular embedded system is designed. Okay. So to serve these different applications, or to serve these different functionalities here, first we need to define a specific task of that embedded system. Okay, and that task is called as purpose of the embedded system. Okay, everyone understood? So if suppose we have designed any one system for a specific application, for example, let's say we will take the case study of the temperature sensor which is available, or temperature analyzer which is available into the iron furnace system. Okay, so here sensing of the temperature and automation of that controlling of the temperature, it is the one task. Okay. The second task is transferring the data from one section to the another section. That means either from the temperature control device to the other devices, or from wirelessly, the data will get transferred from one location to the another location. So this is the another functionality or another task. So in the embedded system, here the combination of different tasks are combined together. Okay. So here, depending upon the design of that system here, or depending upon the functionality of the system, here first we need to analyze the different purpose of the task. Okay. So here every system is having a different purpose. So according to that purpose, here the embedded systems are defined or classified depending upon the task. So in which the first task is the data collection. So in this data collection, what happens here, the system which is designed only to collect the data, okay, or acquisition of the data. So such systems are called as data collection embedded systems. Okay. So here what happens here, this data collection is done for either for storing the data, or for analysis of the data, then manipulation of the data, and the also for the transmission of the data. So here the data refers to the information which is provided to that particular system, either by text, or by voice, or by image, or by electrical signal or analog signal. So these are the different inputs which are provided to the embedded system, and according to that inputs, here the collection of data as well as the manipulation of data takes place. So here what happens, if suppose the data is analog data, then that analog data is first is converted into the digital data by means of using analog to digital converters. Okay, and then that data which is collected is made into the binary equivalent of that particular analog data, and then either the data will be stored or will be transferred to the additional interface which is provided to that particular system. So if we have any system, or if we have one embedded system, okay, then the input to this embedded system is provided by means of the sensors, okay, for collection of the data. So here, whatever the input is provided, if that input is analog input, then that data is first converted into the digital one by means of analog to digital converter, and then that binary equivalent is transferred to the embedded system. Now this embedded system will convert the data into whatever the converted data, binary equivalent converted data. When it receives by the embedded system, either it will store the data into the memory, or it will send the data to any other peripheral or other devices by means of either by manipulation or as it is transferred to the other peripherals, or it will process the data and then it will send to the other peripherals. So here what happens, here the main task of the embedded system is collection of the data which is coming from the input. Okay, so this is the first purpose of the embedded system. So we can call it as either data collection, then the storage of the data, or the data representation. So whatever the data which is coming from the input side, it will get first collected. If it is required, it will get stored into the memory, or if it is required to the other peripherals or other devices, it will get transferred to the other devices. Okay, so this is called as representation. So this is the first task of the purpose of the embedded system, or we can say first purpose for designing the embedded system. So data collection, storage, or representation. Second purpose for designing the embedded system is data communication. So here some of the embedded systems which are designed, these are for deploying the applications, or whatever the applications which are available, which needs to be communicated, or which needs to be transferred from one location to the another location. So in that cases, here such embedded systems are designed. So in this, we can say, if suppose we have some sort of data from the complex satellite systems, okay, so or for satellite communication, here the data is transferred from satellite communication or from satellite to the simple home networking system. Okay, so the data is collected by the embedded systems, and it may require to transfer from one location to the another location, or from one system to the another system. Either it may be located remotely, or it may be available to the nearby. So here in this first, whatever the data is collected into this data collection system, if suppose this is a satellite system, and if we want to transfer it to the home applications, just like set-top boxes, so here what happens, here the data will get transferred remotely from satellite to the set-top boxes. Okay, so here this transmission of data from embedded system or from satellite to the devices which are located remotely is done either by wired network, or by or we can call it as wireline network, or by wireless network. Okay, so here if suppose the data, if suppose it is having too far from that one specific embedded system, it requires the wireless network. But if suppose it is located nearby to that particular embedded system, that can be transferred by wireline network. Okay, so here what happens in this so in this olden days, here what happens, so the data normally is transferred from one embedded system to the second embedded system by means of wireline. But nowadays, here we can use the wireless network also. Okay. So here, this is for this wireless embedded system. We can use the Wi-Fi or for ZigBee or for GPRS system. So by means of that, here the wireless networking can be done. And for wireline network, we can use the RS-232 or USB or TCP/IP protocol. So here also the data communication will take place from one embedded system to the another embedded system. So this is the second purpose of designing the embedded system. Now, third is the data processing. So in data processing, what happens? Already we have explained into the first purpose for data collection, storage, and representation. Whenever we are designing any embedded system, or first we will take the basic of the embedded system. So if suppose this is the embedded system, okay, and whatever the input which is provided to this embedded system is either by means of analog to digital converter, or if suppose that input is digital input, that will get directly transferred, or that data, binary data, is directly transferred to the embedded system, and from embedded system the process data is transferred to the peripheral or will get stored into that into the memory. Okay, so one is called as data collection. Here the data will get collected, then it will get stored, or as well as it will get represented. Okay. Now, whenever the data is coming from the input side, first here the main task of this embedded system is for processing the data. Okay. So if suppose what the input devices is providing the data by means of either text or by means of image or by means of video. Okay. So here whatever the data which is binary equivalent for that particular data, that is transferred to the embedded system. Now embedded system, what will do, will process that data after collection, and then after processing the data, it will get represented or will get transferred to the other peripherals or to the or stored into the storage devices. So here, if suppose the data processing is required, that means here if we want to design a system where whatever the input is provided, according to that input, we need to do some another task. Okay, that means here what happens, if suppose whatever the example which we have taken previously as temperature controller, okay, into the iron furnaces. So here what happens, the task is, if suppose let's assume that if the temperature is above 200 degrees Celsius, here the system or this furnace needs to be controlled, or if it is below, or let's assume 150 degrees Celsius, again we need to start the furnace. So if this is the case, so here what happens, the data, when the embedded system receives the data from these input devices, here what will happen, it will check whether the data is whatever the temperature which is provided to the embedded system is within the range of 150 degree or 200 degrees Celsius. So if suppose it is less than 150 degrees Celsius, what the embedded system needs to do? Embedded system needs to process that. After processing the data, embedded system needs to start the furnace. And if it is above 200 degrees Celsius, embedded system needs to stop the furnace. Okay, so this is the case where the processing of the data which is coming from the input side is required. Okay, so that is done by this specific embedded system. Okay, so this task we can call it as the purpose for designing the embedded system. Okay, now the next one is for controlling the data. Okay, so for control task also, or for automation task also, this embedded system is designed. Okay, so the embedded system with the control functionalities impose the control over the different variables which are provided to that particular embedded system. So here whatever we have taken as the input, embedded system needs to control that input. Okay, and according to that, here the different functionalities is provided to that particular embedded system. Okay, for example, if we take again the air conditioner. Okay, so what is the function of air conditioner? Here it will control the temperature of the room. So the different actuators as well as the sensors which are interfaced or connected to that particular embedded system or for air conditioner, according to that, the air conditioner will sense the temperature. Okay, then if it is in between some sort of range, it will turn on the actuator. Okay, turn off the actuator, and if it is below or above that range, again it will turn on the actuator so that the temperature of the particular room will be controlled. Okay, now also some of the embedded systems are having some application specific user interface. Okay. So what we have seen, data collection, then data communication, data processing, then data control, then we will see some of the application specific interface. Okay, so if suppose the embedded system is designed for some sort of special applications or specific applications, so in that case here what happens, depending upon the applications here, this embedded system is designed with some sort of hardware and software, okay, or hardware and operating system, and then according to that specific application, that application will the data of that application will be either collected, or it will get controlled, or it will get transferred from one location to the another location, or from one device to the another device. Okay, so in that case also, this is one of the purpose of the designing of the embedded system, or this is a specific task designed by the embedded system. Okay. Now one more purpose of the embedded system is the monitoring of data. Okay. Okay. So here in this data monitoring, what happens here? These embedded systems are specifically designed only for the monitoring purpose. Okay, so all the different applications which are related with the healthcare. Okay, so most of these applications are only having the monitoring functions. Okay, so it will determine the different variables or the different inputs which are provided to that particular embedded system by means of the sensors. Okay, then it will not make any control, or it will not automate the data, but it will only represent that data by means of either using monitor or using the different actuators or the drives which are interfaced to that particular embedded system. For a simple example, if we take the example of ECG machine, so what it will do, it will monitor the heartbeat of patient. Okay, and then here, so whatever the machine which is intended or which is connected to that particular patient, the sensor of that particular ECG will have different electrodes or different sensors. Okay, and these electrodes are attached or connected to the human body or human body organs. So from that data here, the data will get accessed or will get received by the embedded system or by ECG, and it will represent only that data, or it will measure that data, and that will get represented on the screen. So this screen is just like we have taken the example of ECG. Similarly, if suppose we have the CROs also. Yes, so for CROs, what we are doing, whenever we are doing the practicals, in that case here, we are connecting the CROs to certain device or the circuitry which we have designed. Okay, now the CRO is only representing whatever the data which is received from that particular circuitry or from that particular system. Okay, so it will not make any type of modification in the data, or it will not manipulate the data, but whatever the data which is received by the system, that will get represented by the embedded system. So this is also one of the tasks which is done by the embedded system. Okay, so everyone understood? So depending upon the different tasks or the application, we can define the different purposes of designing the embedded system. So here the purposes are, first is data collection, storage or representation, then for data communication, that means transferring the data from one location to the another location or from one system to the another system. Then if we want to process the data, that data is also processed by the embedded system. Then to control the data, here the same embedded systems are used. Then for application specific industry or application specific instrumentation, here the embedded systems are designed, okay, for functioning of a specific application. And if you want to represent the data or only to monitor the data, some of the embedded systems are designed. Okay, So these are the different purposes of embedded system. Now we will move towards the next, that is, the time is over, the characteristics and the quality attributes of the embedded system. Okay. Now, if we take the example of general purpose computing system and the embedded system, so unlike the general purpose computing systems, the embedded systems are also having some specific characters, and these characteristics are unique in each embedded system. So depending upon the application which is designed, or the embedded system which is designed for that specific application, here every embedded system is having some sort of unique characteristics. Okay, and some of these characteristics are depending upon the application. So it is called the characteristics which are called as application and domain specific characteristics. Okay. Similarly, the another characteristic is a real reactive or a real-time application characteristics. Okay, so we will write here. The first one is the application or domain specific characteristics, or we call it as domain specific. Okay. Then the second characteristics will be depending upon the output, that is either the output is reactive and whether it is a real-time application or not. So depending upon, here also the characteristics of embedded systems are defined. Okay. Then the operation in which the embedded system is working. So if suppose the embedded system is working in harsh environment or smooth environment, so depending upon that also it has the different characteristics. Okay. Then the fourth is the distributed characteristics. So if suppose the embedded system is having some sort of small systems, okay, which are spread separately, and the collection of the data or processing of the data takes place by many numbers of such embedded systems which are together, then it is called as the distributed embedded system. Okay, and there will be the different characteristics of this different distributed embedded system. Then the next characteristics is the size and weight of the embedded system. So according to that also the different characteristics of the embedded systems are specified. Okay, and the next characteristics depends upon the power requirement of that particular embedded system. Okay, now okay, so we will see each characteristics one by one. So in this application and domain specific characteristics, that if you observe any sort of embedded system, then you will find that each embedded system is having certain functions, and also it is designed or developed to perform a specific application. Okay, so that application depends upon the intended function, or which is for which functionality the embedded system is designed. Okay, so this function for which the embedded system is designed, it is not used for other purpose or for other applications. Okay, so here if we consider the general purpose computing system, then that general purpose computing system can be used for different applications, or the same general purpose system can be used for different applications. But for embedded system, if depending upon the functionality the embedded system is designed, so it cannot be used for other functions. Okay, so for example, if we take the microwave oven, or if we take the air conditioner embedded controlling unit, then that cannot be used, or the microwave oven controlling unit cannot be used for air conditioner, or for air conditioner unit cannot be used for the microwave oven, because the functionality of the microwave oven or functionality of the air conditioner will be the different. Okay, so depending upon the particular domain, the particular embedded system is designed. Okay, so the embedded system will have the different characteristics depending upon the application in for which this embedded system is designed. Okay. Now, if we take the example of the second characteristics is the reactive and the real-time embedded system. Okay. Now, here, if suppose the embedded system is communicating with the real-time world. Okay. So here, this communication takes place by means of either by sensors or by user-defined input devices, and it is connected to the embedded system. Now, any change which takes place into this real-time world or into the input which is provided to the particular sensor, then the sensor will capture that input, and then it is provided to the embedded system. Now, the algorithm which is available into that particular embedded system will run that particular system, and again it will control the other applications or other drives. Okay, so here the response of the embedded system is reactive. That means depending upon the input which is provided to the embedded system, it will react and it will process the data or the process that particular input and will control the output. Okay, so here the processing will be either event triggered or by the real time. So what does it mean? If suppose when communicating with the real world, if suppose the embedded system input is changed, okay, or the sensor which is providing the data to that particular embedded system, if that drastic change takes place by means of event, okay, then such systems are called as reactive systems, and some of the inputs are changed by means of time. That means this particular event will get generated after some sort of periodic event. Okay, so here depending upon the input, so here if suppose it is the periodic event, then the data is predicted one. That means after suppose after 5 minutes or after 10 minutes, if that event is generated, okay, and it is continuous, then here the data is predicted one. That means after 5 minutes the data will get changed. Okay, but if suppose it is event triggered, then in that case here the data is predicted, because here whatever the data which is coming from the sensor, that will not be time triggered. Okay. So not for after a particular period the event will get generated. So event will get generated either in 1 minute or in 5 minutes or will 10 minutes. Okay. So here the data is unpredicted one. Okay. So here depending upon the change in the data, here the embedded system will produce the changes in the output. Okay. So here we can say that the change in the output is the response of the change in the input. Okay. So here, if suppose such sort of embedded systems are designed, then it is called as, or it will be referred as, the reactive systems. Okay. Now, if suppose we take the example of RTOS systems or real-time operating systems, here the behavior of that particular embedded system is deterministic one. That means after a specific time, here the event will get occurred. Okay. So in that case, here the deadline of the task or the deadline of the particular event will be considered, and according to that the system is designed. Okay, so it is called as the real-time operations. Okay, so here the characteristics of the reactive embedded system and real-time operating system will be different depending upon whether it is event triggered or time triggered. Okay. Now if we take the third characteristic, that is the operation. So here, if suppose the embedded system is working into the harsh environment or a simple environment or smooth environment, depending upon that also the characteristics of the embedded system is changed. Okay, so here what happens, here whatever if we take the embedded system which is used into the into high temperature zone, okay, or if we take the example of the embedded system which operates into the area where high vibrations and shocks are available. So according to that, here if suppose the particular embedded system is capable to withstand all these conditions or adverse operating conditions. Okay, so depending upon that also, here the embedded system characteristics are changed. Okay, so for example, if we take the high temperature zone, here the components which are used for designing the embedded system should have high temperature grade. That means that particular embedded system should sustain for high temperature. So here we need not require to consider the cost, or we need not require to consider a simple system which can get adversely affected by the high temperature. So here, depending upon the environment, also we need to design, or we need to select a specific hardware or the sensor or a specific processors for designing this embedded system. Okay, so likewise, depending upon the operation where that particular embedded system is working, so it will have the different characteristics. Okay. Then for distributed embedded system, also we have seen that if suppose if we have a large embedded system, but it is divided into number of parts or number of small embedded systems. Okay, and here the data will get collected from all the devices together, and the data will get processed. So in that case, here what happens? Here a small embedded systems are distributed all over the area, and the data from that all will get combined together into the large embedded control unit, or there will be one controlling unit which will control all the data. Okay, so such systems are called as distributed system. Now, according to that particular system, here there will be the different characteristics of the embedded system. Okay, so we can take the example of automatic vending machine or ATMs. Okay, so here what happens? Each data or each unit will work independently, but the data from every unit will be collected together and controlled together by means of the controlling unit or by means of the controlling embedded system. So such systems are there will be the different characteristics for such type of distributed system. Okay, now depending upon the size and weight, also it will have the different characteristics. Okay, so if suppose we have designed the embedded system just like a mobile phone, okay, then it will have a small size, okay, as well as it will have less weight. Okay, but if we take any other system, okay, for just like for controlling the automotive industry or for controlling the industry automation, so in that case here the size will go on changing, as well as the weight of that particular system also will go on changing. So here, while designing the embedded system, it is considered as the size of the embedded system should be small and weight is also less. Okay, so we can say that if you design the embedded system which is easy to handle and compact, then the compactness and the weight, depending upon the application, there will be the different size and weight or compactness of the system. So it will have the same different characteristics for designing such type of embedded system. So depending upon the application, here also we need to design the embedded system by means of having compact size as well as a less weight. Okay, so here the characteristics of the hardware or the embedded system will go on changing according to that particular application. Okay, now again we need to consider the power consumption of that particular embedded system, or we can call it as the power management of the particular embedded system. Okay, now embedded system should be designed in such a way that it should minimize the heat dissipation. Okay, or we can call it as it will have the less power consumption. So if we require the heat dissipation, we require the unit which we need to cool that particular area, or to cool that particular system. Okay, so again we require the cooling system. Okay, so similarly here, if we want to reduce that cooling system, we need to control the heat dissipation. Okay, similarly for different applications, the consumption of the power should be controlled for designing the embedded system. So according to the application, there will be the different power requirements of that particular embedded system, and that needs to be controlled. So according to that, here the characteristics of the embedded system will go on changing. So if we take if we consider the different areas in which the embedded system is used, we need to consider the characteristics depending upon the application, depending upon the response of that particular embedded system. Then in which area of operation this particular embedded system is used, then how this embedded system is used, whether it is a simple embedded system or it is a distributed embedded system. Here, so depending upon that, also here the characteristics of the embedded system will go on changing. Okay. So we'll stop today. The next is the quality attributes of the embedded system. We will see into the next lecture. Are there any queries? अरे समझले का?